Welcome to CBS Easy.
Hey everyone, and welcome. Board exams are right around the corner, so we're going to do a super fast, super effective revision of one of the most important chapters in physics: light, reflection, and refraction. Let's absolutely nail this in the next 5 minutes.
I totally get it. This chapter can feel like a lot. You've got diagrams, all these formulas, and don't even get me started on remembering if a number should be plus or minus. But trust me, it's actually one of the most logical and high-scoring chapters if you just get those basics down.
And that's exactly what we're about to do. The mission for this session is simple: to give you that ultimate last-minute boost so you can walk into your exam feeling totally prepared. Okay, you ready? Let's dive in.
First up, let's talk about the absolute foundation of this entire chapter. If you get these two sets of laws right, seriously, everything else just clicks into place.
So on the left, we have the laws of reflection. Super straightforward, right? The angle the light comes in at, that's the angle of incidence, is exactly the same as the angle it bounces off at. Then on the right, we have refraction. This is what happens when light bends because it's moving from one thing to another, like from air into water. The big rule here is Snell's law. These two are the building blocks for everything.
Okay, let's move on to our first major topic. And before you start thinking about complicated diagrams, just think about something you use every single day.
Yup, a shiny spoon. This is the perfect real-world example of both types of spherical mirrors. The side you scoop your food with, the part that's caved in, that's one type. And the back, the part that bulges out, that's the other.
So here's the deal. The inside of the spoon is like a concave mirror. It's caved in, see? And the back of the spoon, that's like a convex mirror. That's probably the easiest way to remember the difference between them forever.
Now you're going to want to pay close attention here. This question is a board exam favorite. It comes up all the time, and the examiners are looking for very specific keywords in your answer.
And here it is, your perfect full marks answer. There are two killer points you have to mention. 1, the image is always upright or erect. You don't want to see cars behind you upside down, right? And 2, it gives you a much wider field of view, so the driver can see way more of the road. Those are the magic words.
Awesome. We've tackled mirrors. Now let's level up and see how this all applies when we talk about lenses, which, by the way, are all about refraction.
But before we get to lenses, just look at this glass slab for a second. See how the light ray bends when it enters the glass, and then it bends back again when it leaves? The ray that comes out is parallel to the ray that went in. It just shifted a bit. That's refraction. And that's exactly what's happening inside a lens, just, with curved surfaces instead of flat ones.
So, let's talk about the lenses themselves. A convex lens is thicker in the middle, and its main job is to converge light rays, bring them all to a single point. Think of a magnifying glass. A concave lens is thinner in the middle, and it does the opposite. It diverges or spreads the light rays out. Converging and diverging. You got to know those words.
All right, this next section, this is the secret weapon. I'm not kidding. If you can master this, you will solve every single numerical problem in this chapter without losing a single mark.
It's called the new Cartesian sign convention. Don't let the fancy name fool you. All it means is we're going to treat this like a graph in math class. The center of the mirror or the lens is the origin, 0, 0. And the main line running through it, that's your x-axis. That's it. Here are the 5 golden rules. You need to burn these into your memory. The object is always on the left. All distances are measured from the center. Right is positive, left is negative. Up is positive, down is negative. And listen, here's a little secret. 90% of the mistakes students make in these problems are because they messed up a sign. Get these rules right, and you're already ahead of the game.
Okay, time for the final sprint. Let's get all the essential formulas you need up on the screen. You might want to get ready to screenshot this. First, the mirror formula. Take a look. Notice that big plus sign between the 1 over v and 1 over u? And remember, when you plug in your numbers for v, u, and f, you have to use the sign convention we just talked about. Absolutely crucial. Next up, the lens formula. It looks almost the same, but spot the difference? It's a minus sign. This is such a common place to make a mistake, so just lock it in your brain right now. Mirror is plus, lens is minus. And finally, magnification. This formula just tells you how much bigger or smaller the image is compared to the object. It's the image height over the object height, which also happens to equal times minus v over u for mirrors. Don't forget that little negative sign. It's important.
And here is one last pro tip that'll save you a ton of time. If you calculate the magnification and your answer is a negative number, that automatically tells you the image is real and inverted. If it's positive, the image is virtual and erect. It's a fantastic little shortcut to check if your answer makes sense.
And that is it. In just a few minutes, we've covered the core concepts, the key questions, the secret to the math problems, and all the formulas. You're ready. Go in there, stay calm, and absolutely ace that exam. Good luck!
Thank you for watching with us. See you next time.